October 1944. A muddy field near Aachen, Germany. American combat engineers from the 9th Army crouched beside a German assault gun that had been abandoned by its crew after taking track damage from an anti-tank mine. The StuG III sat silent, its low profile and thick frontal armor still impressive even in defeat. The vehicle's gun pointed uselessly toward a distant tree line, frozen in the position where it had last fired. The American engineers had seen plenty of German armor by this point in the war. They had examined knocked-out Panzer IVs in Normandy, inspected captured Panthers in France, and studied destroyed Tiger tanks in Belgium. They knew German armoured vehicles represented some of the finest engineering in the world. But as they walked around this StuG III, measuring, photographing, and taking notes, they noticed something that made them stop. The gun had almost no traverse. The massive 75mm gun could rotate only 10 degrees to either side. That was it, 20 degrees total. The realization struck them immediately. This seemingly formidable machine, with armor thick enough to deflect most American tank shells and a gun powerful enough to destroy a Sherman at over a kilometer, could barely respond to threats from its flanks. The Germans had built one of their most numerous armored fighting vehicles, but given it almost no ability to engage targets that were not directly in front of it. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This discovery confirmed what battlefield reports had been indicating throughout the campaign across France and into Germany. The StuG III, while deadly in prepared defensive positions, suffered from a critical tactical limitation that American forces had learned to exploit ruthlessly. Its story would reshape American understanding of how armored vehicle design reflected doctrinal assumptions and how those assumptions could become fatal vulnerabilities when combat evolved beyond original expectations. To understand how the StuG III came to have such limited gun traverse, you have to understand its origin and intended purpose. In the late 1930s, the German army identified a critical need for direct fire support weapons to accompany infantry assaults. Traditional towed artillery required time to deploy, was vulnerable to counter-battery fire, and could not keep pace with rapidly advancing infantry formations. The German military theorist Erich von Manstein, then a colonel on the general staff, proposed a solution in 1935. He envisioned a heavily armoured vehicle mounting a powerful gun in a fixed or limited traverse mounting. By eliminating the complex and heavy turret mechanism required for full rotation, the vehicle could mount heavier armour and a more powerful gun on a smaller, lighter chassis. The vehicle would operate as mobile artillery, moving into position, firing in support of infantry attacks, then repositioning as the battle developed. Manstein's concept specifically called for the vehicle to support infantry, not to engage enemy tanks. Anti-tank warfare would be handled by dedicated tank destroyers and towed anti-tank guns. The assault gun's mission was destroying enemy fortifications, eliminating machine gun nests, and suppressing enemy infantry positions with high explosive shells. This doctrinal distinction would prove crucial to understanding both the StuG III's strengths and its fatal weakness. Daimler-Benz received the contract to develop this new vehicle in 1936. Engineers faced an interesting design challenge. They needed a vehicle with the mobility to keep pace with infantry, armour sufficient to withstand enemy fire, and a gun powerful enough to destroy fortified positions. But it also needed to be produced quickly and in large numbers using existing components wherever possible. The solution was elegant. Daimler-Benz took the proven chassis of the Panzer III medium tank and removed the turret entirely. In place of the rotating turret, they built a low, fixed superstructure, housing a 75mm gun in a limited traverse mount. The resulting vehicle was designated StuG III, literally Assault Gun 3, though it would become universally known as the StuG III. The first prototype was completed in 1937. The design featured sloped armour on the front superstructure, providing better protection than the vertical plates common on tanks of that era. The low silhouette, just under 2 meters tall, made the vehicle difficult to spot and harder to hit. The crew consisted of 4 men: commander, gunner, loader, and driver. The commander and gunner worked the main gun. The loader serviced the ammunition. The driver operated the vehicle from a separate compartment at the front. The main armament in early production models was the short-barreled 75mm StuG III gun. This weapon fired a heavy, high-explosive shell ideal for destroying fortifications and infantry positions. The muzzle velocity was relatively low, making it less effective against armoured targets, but that was acceptable since the vehicle was designed to fight bunkers and machine gun nests, not enemy tanks. But here was the critical design feature that would later prove so problematic. The gun had extremely limited traverse. Engineers provided only 10 degrees of movement to either side, 20 degrees total. This was not an oversight or a cost-saving measure. It was a conscious design decision based on the vehicle's intended tactical employment. German doctrine called for the StuG III to operate in prepared positions or during carefully planned advances. The vehicle would approach its firing position with the gun already aimed at the target area. The driver would position the entire vehicle to aim at targets, using the tracks to traverse rather than rotating the gun. Once in position, the limited gun traverse would allow for minor adjustments to engage specific targets within a narrow arc. For its designed mission of supporting infantry attacks against prepared defences, this approach made perfect sense. The StuG would identify enemy bunkers or strongpoints from a distance, approach to effective range, position itself facing the target, and fire until the position was destroyed. The limited traverse was adequate because the targets were static fortifications that did not move. The first StuG III vehicles entered service in 1940 with dedicated assault gun battalions called Sturmgeschützabteilungen. These independent battalions were assigned to support infantry divisions, operating under infantry command rather than panzer command. This organizational structure reflected the vehicle's role as infantry support rather than armored warfare. The StuG III proved highly effective in its designed role during the early campaigns. In the invasion of France in May 1940, StuG III batteries supported infantry assaults against French defensive positions. The vehicles would advance to within 500 meters of enemy bunkers, often much closer, and methodically destroy them with direct fire. French anti-tank guns struggled to penetrate the StuG's frontal armor at combat ranges, while the 75mm gun could demolish concrete fortifications with repeated hits. The Battle of France demonstrated the StuG III's strengths within its doctrinal framework. When employed as mobile artillery supporting infantry attacks against prepared positions, the vehicle excelled. The low profile made it difficult for enemy gunners to target. The heavy frontal armor provided protection during approaches. The powerful gun could destroy virtually any fortification, and the limited gun traverse posed no problem because the targets were stationary and the vehicle could be positioned properly before firing. But the invasion of the Soviet Union in June 1940, and one would change everything. Operation Barbarossa confronted German forces with challenges that their pre-war doctrine had not anticipated. The vast distances, the poor road networks, the aggressive Soviet armor tactics, all combined to push German vehicles beyond their designed parameters. StuG III battalions found themselves engaged in missions far different from their intended role. Instead of supporting infantry assaults against prepared positions, they were increasingly called upon to counter Soviet tank attacks. The T-34 and KV-1 tanks that appeared in the summer of 1941 shocked German forces. These Soviet tanks had armor that the short-barreled 75mm gun on the StuG III could not reliably penetrate. German assault gun crews discovered a terrifying reality. When a T-34 appeared from an unexpected direction, the StuG III could not quickly rotate its gun to engage. The crew had to turn the entire vehicle using the tracks, a process that took precious seconds during which the Soviet tank could fire first. If the T-34 approached from the flank or rear, the StuG was nearly helpless. The problem became worse in close-range engagements in villages and forests. Soviet tanks would maneuver rapidly, using cover and terrain to approach from unexpected angles. The StuG III crews found themselves constantly trying to reposition their entire vehicle to bring their gun to bear. In the time it took to traverse the vehicle using the tracks, a T-34 could fire multiple rounds. Field commanders began sending urgent reports back to Germany. The StuG III needed a more powerful gun capable of defeating Soviet armor, but nothing could be done about the limited traverse without a complete redesign. That limitation was built into the fundamental structure of the vehicle. In response to the anti-armor requirements, German engineers mounted the longer, more powerful 75mm StuG 40 gun beginning in late 1941. This weapon could penetrate the T-34's armor at reasonable combat ranges. The improved gun transformed the StuG III from an infantry support weapon into an effective tank destroyer, but it did nothing to address the traverse problem. By 1942, the German army was producing StuG XVIIs in massive numbers. The vehicle was cheaper to build than a tank, required less complex manufacturing, and used fewer critical materials. A StuG III cost approximately 82,500 Reichsmarks, compared to 103,000 for a Panzer IV. The simpler design meant factories could produce them faster. Germany would eventually build over 10,000 StuG IIIs, making it the most numerous German armoured fighting vehicle of the war. But as production increased, so did frontline reports about the traverse limitation. Crews complained that they could not respond quickly to threats from the flanks. Company commanders noted that StuG IIs were vulnerable in meeting engagements where enemies appeared suddenly from unexpected directions. Battalion reports documented losses, where StuG EIIs were destroyed by enemy tanks that approached from angles the limited gun traverse could not cover. The German army attempted to compensate through doctrine and tactics. Training emphasized positioning the vehicle to cover the most dangerous threat axis. Commanders were instructed to use terrain and concealment to control where enemies could appear. Crews were drilled endlessly on track traverse techniques to aim the entire vehicle quickly, but these were tactical workarounds for a fundamental design limitation. American forces first encountered StuG IIIs in significant numbers during the Tunisia campaign in early 1943. Intelligence officers compiled reports from British forces who had been fighting German armour in North Africa since 1940. The assessments noted that the StuG III was dangerous when encountered frontally in prepared positions, but vulnerable to flanking manoeuvres. American tank crews learned quickly. The StuG III's low profile made it hard to spot, especially in hull-down positions. Its frontal armour could defeat the 75mm gun on the Sherman at most combat ranges. Its own 75mm gun could destroy a Sherman easily. But if American tanks could maneuver to approach from the side, the StuG's limited traverse became a critical weakness. The technique became standard practice. When American tanks encountered StuG III, they would use terrain and concealment to approach from angles outside the gun's 20-degree traverse arc. The StuG crew would desperately attempt to rotate the entire vehicle to bring the gun to bear, but this required time and exposed the vehicle's thinner side armour. American tanks engaging from the flank could achieve kills before the StuG could fully traverse. The Italian campaign provided extensive opportunities to study captured StuG II. American technical intelligence teams examined dozens of vehicles abandoned by German forces during the retreat up the Italian peninsula. Engineers measured the gun traverse mechanism in detail. The mount allowed only 10 degrees of movement to either side, achieved through a simple mechanical system that was robust but inflexible. Reports noted that the limited traverse was not a result of mechanical limitations, but a deliberate design choice. The mounting system could have been engineered to provide more traverse, but this would have required a wider superstructure, more complex mechanisms, and additional weight. German designers had accepted the traverse limitation as a reasonable trade-off for the vehicle's other characteristics. American engineers understood the doctrine behind the design. A vehicle intended to support infantry from prepared positions did not need wide gun traverse. But they also recognized that the rigid doctrinal assumptions had created a vulnerability that became critical when the vehicle was employed outside its intended role. By mid-1944, German forces were using StuG IIs primarily as tank destroyers rather than infantry support weapons. The chronic shortage of tanks meant that assault gun battalions were increasingly tasked with anti-armor missions, but the vehicles had not been designed for this role, and the limited traverse was a severe handicap in the fluid, mobile combat that characterized the Western Front. The American advance across France after the Normandy breakout brought frequent encounters with German armor. StuG III appeared regularly in defensive positions, usually concealed in villages, behind hedgerows, or in tree lines. American tank and infantry teams developed specific techniques for dealing with them. The preferred method was artillery fire. The StuG III's thin top armor, only 10 mm in most areas, made it highly vulnerable to airburst artillery shells. Forward observers would call in artillery concentrations on suspected StuG positions. The high explosive shells raining down from above would either destroy the vehicles or force their crews to abandon them. When artillery was not available, American tanks used maneuver. Sherman commanders learned to use the terrain to approach StuG positions from angles outside the gun's traverse arc. If a StuG was positioned facing north, American tanks would approach from northeast or northwest, forcing the German crew to rotate the entire vehicle to engage. During this rotation, the StuG's thin side armor became vulnerable. Infantry armor coordination proved particularly effective. American infantry would fix the StuG's attention from the front, while tanks maneuvered to the flanks. The StuG crew, focused on the infantry threat directly ahead, would often fail to notice the flanking tanks until it was too late. By the time the crew realized they were being engaged from the side, American tank rounds were already penetrating the thin side armor. Close-range combat in towns and villages was particularly difficult for StuG III crews. The narrow streets and limited visibility meant threats could appear suddenly from any direction. The limited gun traverse meant the crew could not quickly engage targets that appeared from side streets or from behind buildings. American tank destroyers and Shermans learned to use buildings for cover, advancing building to building until they could engage the StuG from the side or rear at ranges where even the thinner armor could be penetrated easily. The captured StuG III, examined by engineers near Aachen in October 1944, provided detailed insights into the mechanical reality of the traverse limitation. The gun mounting consisted of a cradle that held the gun barrel and recoil mechanism. This cradle was attached to a traverse mechanism that allowed limited side-to-side movement. The traverse was controlled by a hand wheel operated by the gunner. Turning the wheel rotated the gun slowly within its limited arc. The system was simple, reliable, and required no electrical power. But it was also inflexible. No amount of mechanical effort could force the gun to traverse beyond its designed limits. The physical structure of the superstructure prevented greater traverse angles. American engineers calculated that in the time required for a StuG III to traverse its tracks to rotate the entire vehicle 90 degrees, an American tank with a full rotation turret could traverse its gun 360 degrees twice. This mechanical disadvantage translated directly into tactical vulnerability. In any situation requiring rapid target engagement at varying angles, the StuG was at a severe disadvantage. The examination also revealed attempts by field crews to compensate for the limitation. Some StuG IIIs showed evidence of modified vision blocks intended to improve the crew's ability to see threats from the sides. Others had additional machine gun ports cut into the superstructure to provide defensive fire against infantry approaching from flanks. These field modifications demonstrated that crews understood the vulnerability and were desperately trying to mitigate it. German tactical manuals from late in the war acknowledged the problem explicitly. A training document from January 1945 instructed StuG crews to position their vehicles so that all likely threat directions fell within the gun's traverse arc. It noted that the commander must constantly assess where threats might appear and position the vehicle accordingly. It emphasized that the StuG must never be caught with an enemy outside its traverse arc, as rotation of the entire vehicle took too long under combat conditions. These instructions represented sound tactics, but they also revealed the fundamental problem. The StuG III required near-perfect positioning and complete awareness of the tactical situation to compensate for its design limitation. In the chaos of actual combat, such perfect conditions rarely existed. American after-action reports from the battles in Germany during Faring, the fall and winter of 1944, documented the pattern repeatedly. StuG IIs positioned in defensive ambush positions remained dangerous, but StuG IIs caught in meeting engagements or forced to maneuver were vulnerable. The limited traverse that seemed acceptable for a vehicle supporting infantry attacks against prepared positions became a critical flaw for a vehicle operating as a tank destroyer in fluid mobile combat. The fundamental lesson was clear. Design decisions based on specific doctrinal assumptions could create vulnerabilities when the vehicle was employed outside those assumptions. The StuG III was optimized for a particular mission, and when German forces needed it to perform different missions, the optimization became a liability. The winter of 1944 brought some of the most intense fighting of the entire war. As American forces pushed toward the German border, they encountered increasingly desperate German resistance. StuG III battalions appeared frequently, often as last-ditch defensive forces attempting to slow the Allied advance. The Battle of the Hürtgen Forest in November and December 1944 provided a particularly harsh testing ground for German armour. The dense forest, narrow trails, and limited visibility created conditions where the StuG III's low profile and heavy frontal armour should have provided advantages. Instead, the close-range combat and sudden encounters from multiple directions highlighted the traverse limitation catastrophically. American infantry and tank teams developed what they called stooge hunting techniques, specifically for the forest fighting. Small combined arms groups would advance through the forest, using the trees for concealment. When they located a StuG, they would split into two elements. One element would engage from the front, forcing the StuG crew to orient their gun toward that threat. The second element would maneuver through the forest to attack from the flank or rear. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The StuG crews found themselves in an impossible situation. The thick trees prevented them from seeing threats until they were very close. The narrow forest trails made it difficult to rotate the vehicle quickly. By the time the crew realized they were being engaged from the side, American bazookas or tank destroyers were already firing into the thin-side armor from ranges of less than 100 meters. German records from Sturmgeschütz Brigade 341, which fought in the Hürtgen Forest, documented the problem in stark terms. Of 22 StuG III lost during a 2-week period in late November, 16 were destroyed by flanking attacks. The battalion commander noted in his report that the vehicle's limited gun traverse made them highly vulnerable in close terrain where enemies could approach from multiple directions. The Battle of the Bulge in December 1944 saw significant numbers of StuG IIs committed to support the German offensive. The attack plan called for rapid advances through the Ardennes forests, seizing key road junctions and bridges. StuG battalions were assigned to support infantry divisions, providing mobile fire support and anti-tank capability. But the fluid, mobile nature of the offensive fighting exposed the StuG III's weaknesses repeatedly. As German columns advanced along narrow roads through forests, American forces would allow them to pass, then attack from the flanks. StuG III caught in column on roads could not quickly engage threats from the tree line. The limited traverse meant only vehicles already oriented toward the threat could fire. The others had to laboriously rotate using their tracks while taking fire. American after-action reports from the Bulge documented numerous encounters where StuG IIIs were destroyed or abandoned after being attacked from flanks. The village of Rocherath saw particularly intense fighting, where American tank destroyers positioned in buildings engaged German armour advancing through the streets. StuG IIIs attempting to support the German infantry advance found themselves unable to quickly engage the tank destroyers, firing from windows and alleyways at 90-degree angles to their line of advance. A technical intelligence report from First Army in January 1945 analysed 23 StuG II captured or destroyed during the Bulge fighting. Engineers examined the vehicles to determine how they had been knocked out. The results were revealing. 8 had been destroyed by flanking shots that penetrated the side armour. 4 had been hit from above by artillery. 3 had been destroyed by close-range infantry attacks with demolition charges. Only 5 had been penetrated through the frontal armour, and 3 of those were at extremely close ranges under 50 metres. The pattern was unmistakable. The StuG III's heavy frontal armour provided excellent protection, but only when the vehicle was oriented properly toward the threat. The thin side and rear armour, combined with the limited gun traverse, created a vulnerability that American forces exploited consistently. The report noted that captured German crews consistently mentioned the traverse limitation as their primary concern when fighting American armour. One commander stated that his greatest fear was encountering American tanks when his gun was oriented in the wrong direction. He explained that the time required to rotate the vehicle using the tracks was enough for an American Sherman to fire 2 or 3 rounds, and that even a poorly aimed round might penetrate the side armour. The mechanical reality of track traverse imposed severe tactical limitations. To rotate a 40-ton vehicle 90 degrees required engaging one track forward and the other in reverse, a manoeuvre that took between 8 and 12 seconds depending on terrain and crew skill. During those seconds, the vehicle was essentially defenceless against threats from the direction it was rotating toward. The gun could not bear. The vehicle was presenting its thin side armour, and the crew's attention was focused on the mechanical process of traversing rather than on engaging enemies. By comparison, an American Sherman could rotate its turret 360 degrees in approximately 15 seconds using the hydraulic traverse system. More importantly, the Sherman could engage targets while moving, while the hull was oriented in a different direction, and could switch between targets at different angles almost instantly. This mechanical advantage translated into overwhelming tactical superiority in fluid engagements. German veterans interviewed after the war consistently identified the limited traverse as one of the StuG III's most serious weaknesses. A former StuG commander named Franz Bakey, who fought on both Eastern and Western fronts, described the problem in detail during post-war interrogations. He explained that the vehicle was excellent in prepared defensive positions where the crew could control the engagement geometry, but in meeting engagements, where contact occurred unexpectedly, the limited traverse often meant the difference between survival and destruction. Baker recounted a specific engagement near Bastogne in December 1944, where his StuG was nearly destroyed because of the traverse limitation. His vehicle was supporting an infantry attack along a road when American tanks appeared suddenly from a side road at a 90-degree angle. His gunner could not engage because the targets were outside the traverse arc. He ordered the driver to rotate the vehicle, but before the rotation was complete, an American tank round struck the side of the superstructure, wounding 2 crew members and damaging the gun mount. His vehicle had to withdraw without firing a shot. The Eastern Front experience paralleled what American forces encountered in the West. Soviet tactical doctrine emphasized mobile warfare, aggressive maneuver, and attacking from multiple directions simultaneously. These tactics were specifically designed to overwhelm German defensive positions and exploit weaknesses in German armor. Soviet tank crews learned that the StuG III was most vulnerable when approached from the flanks. Soviet tactical manuals from 1944 instructed tank commanders to avoid frontal engagements with StuGs and instead maneuver to attack from the sides. The instructions specifically noted that the German assault gun had very limited gun traverse and required time to rotate the entire vehicle to engage flanking threats. The massive Soviet offensives of 1944 demonstrated the vulnerability repeatedly. During Operation Bagration in June and July 1944, Soviet forces encircled and destroyed entire German formations. StuG battalions supporting German infantry divisions found themselves cut off and attacked from all sides. The limited traverse that had seemed acceptable in linear defensive operations became catastrophic when Soviet tanks attacked from multiple directions simultaneously. German combat reports from the Eastern Front in late 1944 documented StuG losses at rates that alarmed the High Command. Sturmgeschütz Brigade 203 reported in August 1944 that of 32 StuG IIs lost in 1 month of fighting, 24 had been destroyed by flanking attacks. The brigade commander's report noted that Soviet tank tactics specifically exploited the vehicle's inability to quickly engage threats from the sides. The problem extended beyond tank combat. Soviet infantry anti-tank teams learned to attack StuG III from the flanks, using the same tactics they employed against German tanks. Soviet combat engineers would approach from angles outside the gun's traverse arc, using terrain and cover to close the distance. Once adjacent to the vehicle, they would place magnetic anti-tank mines on the side armor or throw demolition charges onto the engine deck. The StuG III's machine gun, a standard MG-34 mounted in a ball mount on the front superstructure, provided some defensive capability against infantry, but the machine gun could only fire forward within a limited arc. Infantry approaching from the sides or rear were beyond the machine gun's coverage. The commander could fire his personal weapon through the commander's hatch, but this exposed him to enemy fire and provided limited effectiveness. German attempts to modify the StuG III design to address the traverse limitation came too late in the war to make a significant difference. In late 1943, engineers at Aachen, one of the primary StuG III manufacturers, proposed several modifications. One proposal called for increasing the gun traverse to 30 degrees on each side, 60 degrees total. This would have required widening the superstructure and strengthening the gun mount, adding weight and complexity. Another proposal suggested mounting a small auxiliary turret with a machine gun on top of the superstructure, similar to those fitted to some tank destroyers. This would have provided better all-around defense against infantry and improved the commander's visibility, but both proposals were rejected due to production constraints. Germany needed StuG IIs in large numbers immediately. Any modifications that slowed production or required retooling were unacceptable. A few late production StuG IIs received minor improvements. Additional vision blocks were added to improve the commander's ability to see threats from the sides. Some vehicles received a remote-controlled machine gun mount on the superstructure roof that could be operated from inside the vehicle, providing limited defensive fire without exposing the commander. But these improvements did not address the fundamental traverse limitation. The most significant design evolution came with the development of the Jagdpanzer IV, which began replacing the StuG III in production in late 1944. The Jagdpanzer IV featured improved gun traverse, thicker side armor, and a more powerful engine. But production numbers were limited, and the majority of German assault gun battalions continued operating StuG IIIs until the end of the war. American intelligence analysis, in early 1945, compiled comprehensive assessments of German armored vehicle effectiveness based on 2 years of combat experience. The evaluation of the StuG III acknowledged its strengths but emphasized its critical weakness. The report stated that the vehicle was most effective when employed according to its original design intent, supporting infantry from prepared positions against known threats. But when employed as a tank destroyer in mobile combat, the limited traverse created a vulnerability that skilled opponents could exploit consistently. The report recommended that American forces continue using the tactical approaches that had proven effective. Maneuver to flanks. Use terrain to approach outside the gun's traverse arc. Employ artillery against the thin top armor. In close combat, attack from multiple directions simultaneously to overwhelm the vehicle's ability to respond. These tactics had produced consistent results throughout the campaign and remained valid. The production statistics told the story of German armored vehicle priorities. From 1940 to 1945, German factories produced 10,619 StuG III vehicles in various models. This represented roughly 1/3 of all German armored fighting vehicle production during the war. The StuG III was cheaper and faster to produce than tanks, required fewer critical materials, and could be manufactured in facilities that lacked the sophisticated equipment needed for turret production. But the question remained whether this production priority was wise. Germany produced large numbers of a vehicle, with a critical design limitation. Every StuG III represented resources that could have been used to produce tanks with full turret traverse. The industrial efficiency gained by building simple vehicles was offset by the tactical limitations those vehicles brought to the battlefield. Post-war analysis by military historians has debated this trade-off extensively. Some argue that Germany had no choice but to prioritize simpler, cheaper vehicles, given the resource constraints and production bottlenecks of the later war years. Others contend that building large numbers of flawed vehicles represented a misallocation of limited resources that contributed to Germany's defeat. The American perspective, informed by examination of captured vehicles and analysis of combat results, was clear. Design simplicity that compromised tactical effectiveness was false economy. Better to produce fewer vehicles with better capabilities than large numbers of vehicles with critical weaknesses. This philosophy would guide American tank development in the post-war era. The comparison with American tank destroyer doctrine was particularly instructive. The United States Army fielded dedicated tank destroyers like the M10 and M36. These vehicles mounted powerful guns on tracked chassis, similar in concept to the StuG III. But American tank destroyers had fully rotating turrets, providing complete 360-degree traverse. This mechanical capability supported American tank destroyer doctrine, which emphasized mobility, ambush tactics, and rapid repositioning. American tank destroyers were designed to move quickly to threatened sectors, establish ambush positions, engage enemy armor at range, then displace rapidly to new positions before enemy forces could respond. This doctrine required the ability to engage targets from any direction without repositioning the entire vehicle. A limited traverse mount would have been completely unsuitable for American doctrine. The doctrinal difference reflected different philosophies about armored warfare. German doctrine, at least in the late 1930s when the StuG III was designed, emphasized deliberate, methodical operations with clear front lines and defined sectors of responsibility. Vehicles could be positioned to cover specific arcs because the battlefield was organized and predictable. American doctrine emphasized flexibility, rapid maneuver, and the ability to respond to unexpected situations. American vehicles needed to be capable of engaging threats from any direction because American tactical philosophy expected fluid, unpredictable combat. The contrast in vehicle design reflected these different doctrinal assumptions. By the spring of 1945, the StuG III's vulnerabilities were well documented and widely exploited. American, British, and Soviet forces all employed tactics specifically designed to take advantage of the limited traverse. German crews continued fighting with courage and skill, but they were operating vehicles that placed them at a severe disadvantage in the mobile warfare that characterized the war's final months. The fighting in Germany during the final Allied advance saw frequent encounters with StuG III's defending towns, villages, and river crossings. But these desperate defensive battles only highlighted the vehicle's limitations. StuG III's positioned to defend a bridge could not quickly respond when Allied tanks forded the river upstream and attacked from an unexpected direction. Vehicles defending a town street could not engage Allied armor that appeared from side streets or from behind buildings. A particularly revealing engagement occurred at the crossing of the Rhine River near Remagen in March 1945. German forces attempted to destroy the Ludendorff Bridge using StuG III's positioned on the east bank, but American forces approached the bridge from multiple directions simultaneously. The StuG crews found themselves unable to engage all the threats. While one vehicle oriented its gun toward American tanks approaching along the road, other American tanks maneuvered through surrounding terrain to attack from different angles. Within 20 minutes, 4 of the 5 StuG II defending the bridge had been destroyed or abandoned, all hit from the flanks. German combat reports from the final months of the war repeatedly mentioned the traverse limitation as a critical problem. A report from Sturmgeschütz Brigade 279 inches March 1945 noted that the brigade's StuG III were essentially defenseless against attacks from multiple directions simultaneously. The report requested urgently that replacement vehicles be provided with improved traverse capability, but no such vehicles existed in the German infantry. The last significant combat use of StuG II came during the Battle of Berlin in April and May 1945. Small numbers of assault guns attempted to defend key positions in the city against Soviet attacks. The urban combat environment was particularly unfavorable for vehicles with limited traverse. Soviet tanks and infantry could approach from any direction through the maze of streets and ruined buildings. StuG crews found themselves constantly trying to reorient their vehicles, presenting their vulnerable side armor repeatedly. By the end of the war, the surviving StuG IIs were destroyed by their crews, abandoned due to fuel shortages, or captured by Allied forces. The vehicle that had been Germany's most numerous armoured fighting vehicle disappeared from the battlefield, a victim of both Allied military superiority and its own design limitations. The captured vehicles provided extensive material for post-war analysis. American, British and Soviet technical teams examined dozens of StuG II to understand German design philosophy and engineering practices. The consensus view that emerged was that the StuG III represented a successful execution of a flawed concept. The vehicle itself was well built, reliable, and effective within its designed parameters. German engineering and manufacturing quality were evident throughout. The armour was well sloped and properly hardened. The gun was accurate and powerful. The mechanical systems were robust. The vehicle was easier to maintain than more complex German tanks. From a pure engineering standpoint, the StuG III was an impressive achievement. But the doctrinal assumptions underlying the design proved fatally flawed. The concept of a limited traverse assault gun assumed static warfare, with clear front lines and predictable threat axes. When the war evolved into mobile, fluid combat with attacks from multiple directions, those assumptions collapsed. The design that seemed logical in 1937 was obsolete by 1943. American tank designers studying captured StuG III drew explicit lessons about the relationship between design and doctrine. A vehicle must be designed for the warfare it will actually face, not the warfare its designers assume it will face. Doctrine must be flexible enough to accommodate unexpected battlefield conditions. And any design feature that severely limits tactical flexibility, no matter how much industrial efficiency it provides, represents a fundamental flaw. These lessons directly influenced American tank development in the post-war period. The M46, M47, M48, and subsequent American tanks all featured fully rotating turrets with powered traverse systems. Even tank destroyers transitioned to turreted designs. The limited traverse assault gun concept was completely abandoned as unsuitable for modern mobile warfare. The StuG III's story also provided insights into the danger of over-optimization. By optimizing the vehicle for a very specific mission under very specific conditions, German designers created a weapon that was highly effective in that narrow role but vulnerable in all others. This over-optimization became a liability when battlefield conditions differed from the assumptions. Modern military vehicle design explicitly seeks to avoid this trap. Contemporary armoured vehicles are designed for flexibility and adaptability. While each vehicle has a primary mission, the design must allow for employment in a wide range of roles under various conditions. The ability to engage threats from any direction is considered a fundamental requirement, not an optional feature. The two surviving StuG XX on display today serve as reminders of these lessons. One resides at the German Tank Museum in Münster, Germany. Another is displayed at the Kubinka Tank Museum in Russia. Museum visitors examining these vehicles can see the limited gun traverse mechanism firsthand. The physical reality of the design limitation becomes immediately apparent. Modern military historians view the StuG III as an example of how doctrinal Assumptions can blind designers to obvious vulnerabilities. The vehicle was designed to support infantry attacks against fortified positions. Within that role, limited traverse seemed acceptable. But when the vehicle was pressed into service as a tank destroyer, a role it was never designed for, the limitation became critical. The irony was that Germany was forced to use StuG IIs as tank destroyers precisely because the resource-intensive production of proper tanks was beyond German industrial capacity by mid-war. The vehicle built to save resources by eliminating the complex turret mechanism became the primary tank-destroying vehicle because Germany could not produce enough actual tanks. The design compromise that seemed economical in peacetime became a tactical vulnerability in wartime. For the American engineers who examined that first captured StuG III near Aachen in October 1944, the limited traverse was immediately recognizable as a critical flaw. These men had experience with American tanks and tank destroyers. They understood that modern mobile warfare required the ability to engage threats from any direction. They recognized that the German vehicle's design reflected outdated assumptions about how battles would be fought. Their detailed reports contributed to American understanding of German armored vehicle design philosophy and its weaknesses. These assessments informed tactical decisions throughout the final months of the war in Europe. American units receiving intelligence briefings on the StuG III were specifically instructed to exploit the traverse limitation through flanking maneuvers. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.